Hi there. This is a video about parent functions. In this video, we're going to be talking about the various different kinds of parent functions and their graphs. Now, the reason why we call these parent functions is because these are the most basic, easiest functions to graph, okay? And let's jump in and talk about a couple. The first parent function I want to talk about is the function f of x is equal to x squared. All right, so whenever you see a function that has x raised to the second power, this is the most basic function you can have for a polynomial of degree 2 or just an x squared function. So what I want to do is come in here and let's make a table. All right, so let's make a column for our x values and then a column for our function values, also our y values. And when I do this, I always plug in the same x values, -2, -1, 0, 1, and 2. All right. And what I want to do is take these values, the x values. Remember, we choose our x values. We plug those into our function and we generate y values. All right, and we're going to graph those. So if I plug those in, let's just do f of -2 first. That means we're taking -2 and we're squaring it. So -2 times -2 gives us a value of +4. All right, so that's the y value when x is -2. The next one is f of -1. So if we take -1 and we square that, -1 times -1 gives us +1. Okay. If we plug in 0 into our function, we get 0 squared. 0 times 0 is just going to give us 0. All right. If we plug in 1, 1 squared means that we're just going to have 1. 1 times 1 is 1. And then let's do f of 2, plug that in. There should be a 1 there. That means we're doing 2 squared. So f of 2 means we're going to do 2 times 2, which is 4, and that's our y value. All right, so these are really important values here because we're going to use those to now graph this equation, okay? And so from here, what I want to do is plot these points. So 1, 2, 3, 4, 1, 2, 1, 2. So we got the point -2, 4. All right, remember the table values just become points on a graph. So -2, 4 is here. -1, 1 goes here. 0, 0 goes here. 1, 1 is here. And then 2, 4 goes here. All right, so what I want to do is come in here and connect those. And this is going to be a graph of a parabola. All right, and so that's the idea on something like this, is that our function, f of x is equal to x squared, is this graph, okay? It's important that these points, all right, that we memorize or know these points that are on this graph, okay? Because those, points are going to help us when we do transformations. All right, let's take a look at the next function. The next function that we have is the function f of x is equal to x cubed. Okay, so this is x to the third power. And what I want to do is the same exact thing. All right, let's create a table of values. And we're going to do the same thing of choosing our x values. And I always choose -1, -2, 0, 1, and then 2. All right, if we substitute these values into our function, we're going to get -2 and then cube it. All right, now -2 cubed means that we're doing -2 times -2 times -2. Which -2 times -2 is +4 times another -2 gives us a -8. All right, so f of -2 is equal to -8. All right, so that's the y value there. If we plug in -1 into this function, we're going to get -1 cubed. -1 times itself 3 times. It means that we're going to take -1 times -1, which is +1, times another -1 gives us a -1. So f of -1 is equal to -1. All right, and then let's plug in f of 0. So we get 0 cubed. 0 times itself 3 times is still just going to give us 0. Let's plug in 1 into this function. So f of 1 means we have 1 times itself 3 times, which is just 1. So we get 1, 1, and then when we plug in 2, put that here, f of 2 means we're taking 2 cubed, which means 2 times 2 times 2, which means that we get a value of 8 out of that. All right, so that's our parent function. This is our the values for this function f of x equals x cubed. All right, again, these are the points on the graph, so let's take those values and graph them real quick. All right, so if we take those points and we plot them, all right, -2, -8 is down here. -1 is here. 0, 0, 1, 1, and then 2, 8, all right, is here. And if we connect those with a line or a curve, we get this as our graph. So that's our standard parent function for f of x equals x cubed. All right, so that's our cubic function. Okay, the next function is the absolute value function. And again, I'm going to do the same thing. We're just going to make a table here. Choose our values for x, -2, -1, 0, 1, and then 2. So -2, if I plug that into my function, so f of -2 means I'm taking the absolute value of -2. The absolute value of -2 is 2. And so, that's the point on that graph, all right, for that point. Let's plug in -1. If I plug in -1, I'm going to take the absolute value of -1. The absolute value of -1 is +1, so I'm going to plug that in here. Let's plug in f of 0. The absolute value of 0 is just 0, all right, so f of 0 equals 0. If I plug in 1 into this function, absolute value of 1 is going to be 1. All right, so f of 1 is equal to 1. And then if we do the f of 2, the absolute value of 2 is just going to be 2. All right, so just plugging these numbers in, generating more points. And so from here, all right, let's graph these. All right, so 1, 2, 1, 2, 1, 2. So we, again, these are the points on our graph. So -2, 2, -1, 1, and 0, 0, 1, 1, and 2, 2. All right, and so this is what our graph looks like for an absolute value function. Okay. The next parent function that we have is f of x is equal to the square root of x. On this one, what we have to remember is that whatever we put in our underneath our radical has to be greater than or equal to 0, okay? We can't take the square root of a negative number, so we can't plug in negative values, all right? And so that's, our domain for this. And so what I want to do, if we're choosing x values for this function, what I want to do is choose the value 0. I'm going to choose the value of 1. I'm going to choose the value of 4, and I'm going to choose the value of 9. Okay, now I've chosen different values for this function because I want to make sure that I can take the square root of these numbers. That's why I chose, 1, 4, and 9 is because those are numbers I can take the square root of. So if I plug in, say, f of 0 here, this is going to be, the square root of 0, which square root of 0 is just 0. All right, so f of 0 is equal to 0. If I plug in 1, f of 1, that's the square root of 1. All right, so f of 1, square root of 1 is just 1. And then f of 4 means that I'm taking the square root of 4. All right, so the square root of 4 is 2. So f of 4 is equal to 2. All right, and then f of 9, all right, so f of 9 means I'm going to do the square root of 9, and that's going to give me a value of 3. So f of 9 is equal to 3. All right, that's why I chose those values, because these are the ones that are going to work the best for choosing those x values. And so let's go ahead and graph this. And so because we don't have any negative numbers, I'm just going to leave it as such. But let's do 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 1, 2, 3. All right, so I know I have the point 0, 0. I have the point 1, 1. I have the point 4, 2. And then I have the point 9, 3. Okay, and so my graph is simply just going to look like this. All right, and that's the idea on a graph like that for f of x is equal to the square root of x. Our last one that we're going to talk about today is f of x is equal to 1 over x. This is a rational function, and it's rational because our variable is in the denominator of a fraction. Okay, the one thing that we have to talk about here is the fact that x cannot be equal to 0. All right, so you know, this is what we call a domain restriction, and we can't do that. The reason is because if you take this and you do 1 divided by 0, that gives you an undefined value if you plugged in 0, and that doesn't work. So you can't divide by 0, therefore we can't plug in 0. So what I want to do is do the same thing. Let's make a table. So x and then f of x values. Let's choose negative, you know, -2, -1, 1, and then 2, okay? And so if I plug in, you know, -2, so f of -2, it means we're going to do 1 over -2, so that's -1/2. All right, f of -1 means I'm going to plug in -1. So 1 divided by -1 is simply just going to give us -1. So f of -1 equals -1. If I plug in 1, f of 1 means we're going to get 1 over 1, which is going to give us just 1. And then if we do f of 2, all right, f of 2 means we're going to do 1 over 2. Plug that in, and that's just going to give us 1/2. Now, the graph of this is a little bit weird. I could probably do some more points, but the idea is that if we draw our graph like this and we do the points, you know, 1, 2, 1, 2, 1, 2, 1, 2. I have the points 1, 1, and -1, -1. I have the points 2, 1/2, and I have the point -2, -1/2. And what happens is you get this graph that looks like this, all right? And this is just your typical rational function graph, okay? Where your graph is going to look like this. Because we didn't plug in 0, we have this thing called a vertical asymptote at 0. All right, so you know, at the line, you know, x equals 0 or the y-axis, that's a vertical asymptote. It means our graph is going to get really, really close to that, but it's never going to touch. And then it jumps down here, and it pops out like that. So that's the idea. All right, so let's recap on all of these and kind of talk about what the expectations are for you, and you know, what this looks like when we talk about parent functions. All right, so parent functions overview, you know, I want to talk about a couple, you know, the ones we just talked about. So f of x is equal to x squared. You know, all this is a parabola like so, all right? You know, where you have y-intercept of 0, just your standard parabola, all right? F of x equals x cubed is just going to look like this, all right? If you had f of x is equal to the absolute value of x, you know, that's just going to be a graph that looks like this. If you've got, say, f of x is equal to the square root of x, then that graph is going to look like that. If you've got f of x is equal to 1 over x, this graph is going to look like this. All right, and so, you know, the goal of this is to not necessarily, you have to just know what the basic graphs look like. I'm not, you know, and you can generate these by plugging in values, and you should know the points on each of these functions, but to just know their general shape is really important. All right, this is probably the basic piece, but it's also something that you have to make sure that you, number one, just know what these graphs look like, but also know how to get them. So that's the idea. Hope you enjoyed this video. Hopefully this makes sense as to how we get parent functions. And then, we'll talk more about how we can transform them. Thanks. Talk to you soon. Bye.